Academy. I am Atul Negi and I welcome you all in this foundation course on theory of machine subject. So in this foundation course, we are discussing very important concepts of theory of machine subject, in which we have started with the chapter first, that is simple mechanism. And the intention behind this foundation course is to basically focus on the fundamental parts, to focus on the basic parts where actually most of the students have some lack of information is there. They are not good enough in the fundamentals, and that's why it is difficult for them to understand the application part. So in whole course of foundation, we will be focusing on the fundamental things, basic concepts we are working here, so that we will be in a situation to understand all application based problems as well. So there is a situation when students are facing difficulty in application related numericals or application related questions because the fundamentals are not clear, right? So we are doing all those fundamentals. We will discuss everything which is what required to understand this particular theory of machine subject, right? So in today's session, the topic will be the velocity analysis, and in the GATE examination specifically, every year you will be seeing one question coming from the velocity analysis. And in velocity analysis, we have two different methods: relative velocity method, and the second is the eye center method. Both the methods we are going to discuss in this particular lecture. Okay, first we are going to discuss relative velocity method, and maybe in the second lecture we will discuss about the eye center method also. Now in the questions, whatever questions coming in the GATE examination, both the methods can be used. It depends upon you in whichever method you are convenient, right? So we will try to solve question from eye center approach also and relative velocity approach also. Both the approach we are going to use here. Is that clear, everyone? So please focus on this particular lecture, as it is very, very important with respect to competitive examinations like GATE and engineering services prelims, right? And we will see all the questions, whatever question asked in GATE, we will try to solve in the class itself. Few questions we'll solve today and few questions in the upcoming sessions also. So this whole velocity analysis will be covered in 3 lectures, so that we will have sufficient time to solve all PYQs, right? So before starting the lecture, guys, just a small advice: join this particular Telegram group, so that you will be getting all important notifications of the latest job recruitments, and as well as some quizzes we are running in the Telegram group, so that it will help you in your test preparations as well. And also whatever the YouTube events that we are going to conduct in IMS GATE Academy YouTube channel, you will get all the information in this particular channel. So the link is given in the description also. You can directly click on that link and you can join this Telegram group as well, right? Okay, and we have started already our IMS GATE Academy live online program, and it contains more than 800 hours of sessions. Apart from that, you will be getting 12 mentorship sessions. These sessions will be one-to-one sessions, personalized sessions, and you can discuss your whatever the difficulty or challenges that you are facing in your GATE preparation. So you will be having always a direct contact with the faculty. And the lectures, live lectures, are interactive lectures, which means in the lecture itself you can ask the question. It doesn't mean that you are just watching a video. In the live classes, you can have a liberty to ask question. You can ask the question in the live class itself, okay? And doubt solving portal is also provided separately, where you can post your questions. You can post the image of the questions also. Apart from that, theory book, exercise book, and GATE previous year question booklet is also given. And finally, mock test series, online test series is also provided, where chapter test, subject test, and a full length mock tests are provided. So these are the features of IMS GATE Academy program. And if you want to join IMS GATE Academy live program, you can directly call on these numbers, right? These numbers you can call and book your free counseling sessions. Okay, if you have any doubt regarding how to join IMS GATE Academy live program, you can directly call on this number. So our counselor team will be there. It will ready to help you out if you have any challenges while enrolling in the IMS GATE Academy live program. So you will get all the helps. Okay, so just you can call on these numbers directly, right? Now we'll start the session with the velocity analysis. Okay, everyone. Now before starting the velocity analysis, we need to know some basics of the motion part. Okay, we need to know what is the basics part. So if I ask you, like, what is motion? So what you will say? If I ask you what is motion, what will be your answer? Tell me. What will be your answer? Motion means what? When there is a change in position. Whenever there is a change in position, we can say motion is there. Okay. Always remember, whenever we want to analyze the motion, we need to look at the change in position. Okay. Change in position. So whenever change happens in the position, we can say there is a motion. Okay. So whenever position is changing, okay, obviously continuous change in position it is there, which means whenever position is changing, motion is there. Simple logic, right? So we will first look at focus on what? Position. Second, we will be focusing on the displacement, because position is going to change, displacement will be there. Displacement change will be there, velocity will be there, and this velocity changes are there, it means acceleration is there. So all are what? Motion related parameters. So whenever we want to do any motion analysis, we need to focus on position. We need to focus on displacement. We need to focus on velocity. And third, we need to focus on acceleration. We need to focus on acceleration. Okay. These are the 4 fundamental parameters that you need to look whenever motion analysis we want to do it. Is that clear, everyone? These are the 4 basic fundamental parameters in which we need to look for. We need to look for these 4 fundamental parameters whenever we want to do motion analysis. Right? Fine. Now, before going further into velocity analysis part, first of all, we will discuss like what are the types of motions we can have. Once that part is clear, then we can easily enter into velocity analysis also. So first of all, we need to know different types of motions as well, right? So let us write types of motion next. Types of motion. Okay. Now in types of motion, first of all, we will be having translation. Second, we will be having rotation. And third, we will be having combination of translation and rotation, which is called as general plane motion. General plane motion, or in short I can call it as T plus R, translation plus rotation. Clear? Translation is there, rotation is there, and the combination of translation and rotation, that is T plus R, which is also known as general plane motion. These are 3 different types of motions we will have. So whenever there is a motion happening, we will see whether it is translation or rotation or combination of both. Right? So in a mechanism, we are discussing our subject theory of machine. Here we will be talking about the machine and mechanism. Whenever any part of a machine or mechanism is moving with respect to another part, we need to figure out what kind of motion it is doing. Okay, so that we can easily do the analysis. Let's suppose if it is having translation only. So what kind of velocity, accelerations, displacement will be there? That part we will discuss. If combination of translation and rotation is there, so we'll see how we can calculate velocity and acceleration part. Right? So that's why, first of all, I will discuss the translation part. Very basic thing. In engineering mechanics, we have discussed this part also. Let's suppose if I discuss this translation part. Let me write it this translation here first. Right? Now see. in translation, what happens? Let me draw one body here, okay, with respect to which we will talk about the translation. So let's suppose this is a horizontal plane. On this horizontal plane there is a body, okay, there is a body we have kept here. Now it has moved till this point, right? Now everyone see, there are two different points I'm considering here, point A, point B. Okay, there is a point A and point B here. Now when this body has moved from this position to this position, you will notice that it is following a straight line path. It is following a straight line path. Is it clear? Right? Now while doing this straight line path, you will notice one thing, that whatever the displacement or the distance moved by point A, same distance will be moved by the point B also. Let us consider point A and B here also. This is point A and point B. So I can easily write one thing here, the displacement of point A equals to displacement of point B. Right? Is it clear? Now, second thing, if displacements are same, so velocity will also remain same. Acceleration will also remain same. Right? So here you will notice one basic point, that all the particles, I have just for example I have taken two particles. It may have like n number of particles, right? But one thing I can say with full surety, that all the particles are moving with same displacement, all will have same velocity, all will have same acceleration, which means each and every particle on the body is having exactly same motion. Each and every particle on the body is having exactly same motion. When it is there, in that case there is no need to represent entire body. I can simply represent this body as a point mass having same mass value mkg. Let's suppose the mass of this block is mkg. Same I will be considering, and I will say ki it is having a velocity v, meter per second, acceleration a meter per second square, like that. So please understand this point very carefully. Whenever body is having a translation, see, translation, again two types of translation we have, rectilinear translation, curvilinear translation. The most important fundamental part of translation is each and every point on the given body is having exactly same motion. When I say exactly same motion, it means displacement, velocity and acceleration are same. Displacement, velocity and acceleration are same. I hope it is clear, right? So it is not necessary that always it will move in a straight line. It can move in a curve path also. It is called as curvilinear translation. Clear? So main understanding of translation is entire body, okay, entire body. In that body, let's suppose consider number of particles, n number of particles. All the particles is moving with same velocity, same acceleration and same displacement will be there. So exactly all the particles is behaving in a same way with respect to motion I am talking about. When I say motion, these are the three parameters that we need to look. Okay, fine. So that is what the translation. Now, but the same thing we cannot tell about the rotation part. Rotation is different with respect to translation. Okay, so translation has two parts, rectilinear and curvilinear. I have given the example of rectilinear translation. Most of the time many students are confused ki translation means a straight line motion. No, in the curve path also we can have a translation. So in the curve path also, again this point will be valid. Displacement is same for all the particles, velocity is same all the particles, acceleration is also same for all the particles. This definition will remain as it is for curvilinear translation also. Fine. Okay. Now next move to the rotation part. Clear? Rotation part. In rotation, what happens? See, let me just draw the diagram here first of all for you. So let's suppose this is a hinge joint I'm drawing. Okay, now this is point A, this is point O. Now, and one important thing is that it is rotating with angular velocity omega. Clear? Rotating with angular velocity omega. I need to write the velocity of point A. So how I'm going to write the velocity of point A? Like this. This is the velocity of point A, which is equals to distance of point A from the point of rotation, that is OA distance, multiplied by omega. And one more thing, this velocity will be perpendicular to this link. Perpendicular to this link. Now, this direction is very important, guys. This velocity vector is drawn perpendicular to this link. Why is it so? Why is it so? Because what happens whenever this rod, let's suppose this rod is what rotating, obviously if I talk about this point A, it will follow this curved path. It will follow this curved path, right? Because point A is under rotation with respect to point O. With respect to point O, A is under rotation. So when it is rotation, it will follow this curved path. And what is the definition of this direction? Direction will be always tangent. Direction will be always tangent to the path. So tangent to the path will become automatically perpendicular to the link. Tangent to the path will become what? Perpendicular to the link. That's why this perpendicular, this 90-degree thing you should remember, that velocity vector perpendicular to this link. This is very important. While drawing the velocity diagram, this definition or this important meaning how to draw the velocity vector should be clear. If you don't know how to draw velocity vector, then you cannot solve the question with the help of velocity diagrams. Because in order to draw velocity diagram, we need to know how the velocity vectors we need to draw. Right? So velocity vector, how we need to draw? This point, it should be clear to everyone. Simple logic, velocity vector is tangent to the path. Path is this one. This is the path, curved path, because point A is under rotation with respect to O. Tangent to the path will be like this. So when it is tangent to the path, it will become automatically perpendicular to the link. Right? So I hope it is clear. Okay. Fine. Or let's suppose if I consider another point also. Let's suppose this point B. B point I have considered. So how I will write velocity of B? Distance of point B with respect to point of rotation O multiplied by omega. Now one thing, if I ask you to draw the velocity vector, it will be drawn exactly same length as that of velocity vector of point A? No, obviously it will not be there, because the velocity vector of B will have a same direction, but the point is it will have less value compared to the velocity of A, because OA distance will be more compared to OB. Omega is same. Omega value will remain same for A and B. But the point is distance of B with respect to O is less compared to distance of point A with respect to O. So VB value will be less compared to VA. So that's why small length we need to draw compared to this VA. Right? So that's how we have to show the velocity vectors. Fine. Now, next case is the combination of translation and rotation. Now, see. Translation plus rotation, or we can say general plane motion. General plane motion. Now, see, let me show you some examples here. Now, so this is the rod that I have put here. This is the rod that I have kept here. See, this is the rod AB, which has been kept in this particular position. This is the floor and this is the wall. Now, what happens when it is going to slip? So, when it is going to slip, what kind of motion you will see? It is a pure translation. Will it be a pure rotation or combination of translation and rotation? What will be your answer? When it is going to slip, what kind of motion you will observe here? Everyone, please tell me. What will be your answer? Will it have a pure translation or pure rotation? It will be what? Combination. How? Please see. So when it is going to slip, one thing is sure that it will have this final position like this. It will have this final position. Yes or no? This kind of final position it will have when it is going to slip. Obviously, point A will come down, point B will move towards right. In doing so, you have observed that this point A has been moved in the vertically downward and B has moved in a horizontally, okay, towards the right. In this case, translation also occurred, rotation also occurred. How rotation occurs? Because initially angle was theta1, now angle is theta2. So there is what? Some rotation. Now actually, such cases of translation and rotation, how we will consider? Such case of translation and rotation, how we will consider? We will assume first, so let's suppose this was the initial position. We will assume first translation occurred. So first translation occurred, then we will assume rotation occurred. So when rotation occurs, finally it will be like this. So in order to understand translation and rotation combination, which is what? General plane motion, first we will assume translation, then we will assume rotation, and then we will merge both the things and we'll get the resultant answer as well. Okay, so the way how to analyze general plane motion is very important to understand. In engineering mechanics lecture also we will discuss those things, but here at this point of time you should understand the AB initially it was like this, after some time, after slipping it will like this. Now this motion from this to this, we can consider that both translation and rotation happens simultaneously. It's not like if first translation happens then rotation happens. This is what I am assuming for my analysis part. So for my convenience, I've taken first translation, then rotation. But in reality, translation and rotation both occur simultaneously. Okay, very, very important point. Translation and rotation occur simultaneously only, right? Okay. Now, one more example I will give you. Okay, one more example we'll take. Okay, so what happens here? It is having rotation as well, translation as well. So this is an example of rolling. Very common example, and in this example, lot of questions can be framed. Lot of questions can be framed on this example of rolling. Omega angular velocity and V velocity, with V velocity it is moving. So this is a case of slider. Okay, simply ladder case you can say, or any bar or any rod simply. Okay, or ladder also you can consider, no issue, right? Now next, I hope all three motions is clear to everyone. So we talked about translation, rotation and general plane motion. So very basic thing. Now coming to the concept here regarding the velocity analysis, as I told you, there are two methods, relative velocity method and the eye center approach. Okay, So let us discuss both the methods here. First, relative velocity we will be discussing. Okay. Velocity analysis. So the first method we have is relative velocity method. Second is eye center method. So two different approaches, relative velocity and eye center approach. Clear? So we will first discuss relative velocity approach, and then upcoming lectures we will discuss eye center also. Now, okay. Now see how we will write here. So first of all, some basics I am going to discuss. Let's suppose this is y-axis and this is horizontal x-axis. Now, very basic example I am taking, okay, just to give you an idea how to approach this relative velocity, okay. So any random body I have taken, right? In this random body, I have considered 2 points. I will consider two different points here. Point A, another point is point B. Now, as I have mentioned, but I have mentioned the coordinates. So purpose of coordinate is what? To identify the position. Okay. To identify the position, we need what? Coordinates. A reference system is what needed. Without any reference, how you will mention the position? If I have to mention or tell the position of any body or any particle or anything, I need some reference system. So that's why this xy axis coordinate system I have drawn. So that from this origin I will measure the simply their positions, right? Okay. Now position of B will be mentioned like this. Position of A and position of B I have mentioned. Now one more thing. Position of B with respect to A I can write like this. Position of B with respect to A will be written like this. Okay. So this is position of A. This is position of B. This is what? Position of B with respect to A. Okay, let me write it here itself. B with respect to A. B with respect to A means I have written the position of point B considering A as a reference. Considering A as a reference. So this B with respect to A means position of B we have written considering A as reference. And all other like RA, position of point A with respect to this reference. Position of B with respect to this reference. Like this. Now from vector knowledge, from basic vector knowledge you can understand that, see, first of all these are vectors, position vectors, right? So we should mention this arrow because all are vectors here. Okay, all are vectors. Now see, everyone, position vector of B can also be written as position vector of A plus position vector of B with respect to A. This is a very, very important relation. And whole analysis will be based on this one. Okay. Let me write it here. Position of point B is equals to position of point A plus position of point B with respect to A. So what I have done here, simply this is what vector addition, R A vector, R B with respect to A vector. So these vectors are in order and the resultant of these two vector R and B with respect to A will be RB only. So that is simple vector addition. Okay, that much basics you should know. This is vector 1, this is another vector, right? So the third vector which is closing the shape will be called as the resultant. So this is, let's suppose A, this is B. Resultant of A and B will be this R. How we have decided it is a resultant? Because it is in the opposite order. A vector, B vector are in order, but the third vector is in opposite order. Order means what? This is tail of vector A and this is head of vector A. This is what? Tail of vector B, this is head of vector B. Now this is the head of vector R and tail is like this. Tail head, and here head tail it is coming opposite to the order. That's why it is resultant, which is also closing the shape. Resultant will be that vector which is closing the shape. So this basic vector addition at least you should know. So I hope this point is clear. Now, if it is a position vector, velocity can also be written as velocity of point B. Velocity of point A. Velocity of point B with respect to A. And in a similar way, acceleration of B equals to acceleration of A plus acceleration of B with respect to A, like this. Clear? Is it clear, everyone? So these relations are very, very important to analyze any mechanism, okay, with respect to velocity analysis. All these relations are important. So what we have done, in order to write the velocity of point B, if I am having the information of any other point, see, understand, in this body itself you can understand one thing. This body is what? Having a motion. Assume it is having a general plane motion. Very simple example I will take. Not a pure translation, not pure rotation. Rotation and translation both are occurring. Both the motions are involved. Now very important point. Let's suppose I want to know the velocity of point B, or I want to know the acceleration of point B. But in that question, any other point, let's suppose any other point is A. For point A, velocity and accelerations are given. Velocity and accelerations are given. So then it becomes very easy to write velocity and acceleration of point B. So this point you should remember. Whenever we have a information of velocity and acceleration of any one point, based on that point, I can calculate velocity of any other point on the given system using this approach. So you should understand when I am writing this thing, this velocity, let me write it here. Better I will write here. Velocity of B with respect to A. This is velocity of B with respect to A. Velocity of B I am writing with respect to A, which means A becomes my reference point. Okay, A becomes my reference point. So reference point will be that point for which we have the informations like position, velocity or vector, acceleration. So reference point becomes that point for which information is given in the question. Okay, I hope you will remember this point. Got it? Okay, now I will give you one example here, how to understand this particular example. You will get an idea. Okay, this relative velocity concept, how to apply, how to implement, you will get one idea here. Okay, so just look at here, everyone. So this is point A, this is point O, this is point A, this is point O, right? Now second thing, in the question it is given that it is rotating with omega. I need to write the velocity of point A. I need to write velocity of point A. What I will do, I will write it like this. In writing velocity of point A, can I take O as a reference point? Yes. Now you will be thinking, sir, why you have taken O as a reference point? Because for O point, I know the velocity. What is the velocity of point O? In this given system, what is the velocity of point O? 0. 0. Okay, so O will be considered as a reference point because for that point, I know the values. So O will be my reference point. So velocity of O plus velocity of point A with respect to O. Velocity of A with respect to O. Because O is my reference point. Why it is considered as a reference point? Because for that point velocity value is known, which is 0 here. Okay, so finally velocity of A will be nothing but velocity of A with respect to O. So point O velocity I am going to write considering O as a reference. So from this reference point I will observe A. So considering O as a reference point, if I want to observe point A, what I will observe? We will observe what? We will observe only the rotation. Please understand everyone. If I consider point O, okay, if I consider point O and if I observe A, so let us suppose you are sitting at point O. You are sitting at point O and observing A. So what you will observe? Point A is under rotation. So when it is under rotation, you will be having this formula, na? OA multiplied by omega. Right? Hi Ritik, hi. Okay. So please everyone, if you have any doubt and any question regarding this thing that we are discussing here, please ask. Okay. Anything if you want to ask regarding this simple mechanism topic that we are discussing in this foundation series, you can comment in the live chat as well as in the comment box also if you have any doubts or any of the topic in which you are facing problem. Again, one more thing I want to add here. In any of the topics in which you are facing difficulty or some challenges you are facing in order to understand that topic in theory of machine subject, please mention in the comment box. I will make sure that I will do one live session on that topic, and all of your doubts I will discuss there itself. So in the live session only we will be discussing all your doubts. Or if you want me to take any one session regarding any of the topic in which you are facing difficulties, I will do that one also. Right? So if you have any concerns, please mention in the comment box also. Right? I will definitely try to make sure that all of your concerns will get resolved in the live class itself. Right? Okay. So I hope you got the idea of this relative velocity. Right? I hope you got the idea. What we are going to do, we will take one point as a reference. Reference point will be that point for which we have the information. Simple. Okay, that point becomes our reference point. Okay. Got it? This example also we have discussed. Now, what we will do, we will draw the velocity diagram of the mechanism. So what is the basic mechanism that we will discuss first? Already I have told you there are total three mechanisms we are having. 4-bar mechanism, single cylinder crank mechanism and a double cylinder crank mechanism. So what we are going to do, we will discuss the 4-bar mechanism, because in the gate examination you will observe that always questions are coming from 4-bar mechanism. Okay, all the questions you will see from the 4-bar mechanism. So if you are able to understand how to draw the velocity diagram of a 4-bar mechanism, then it will be very easy for you. Single slider crank mechanism also we will discuss, right? No problem at all. But first of all, you need to understand how to draw velocity diagram of 4-bar mechanism. Now once it is clear, I can guarantee you that all other mechanisms you can easily draw, because the procedure is same. Because the procedure is same, right? Whatever the procedure that we are going to follow in 4-bar mechanism, same procedure we need to follow in other mechanisms as well. And we can easily draw the velocity diagram, right? Okay. Now, we will discuss the 4-bar mechanism, guys. So, this is the 4-bar mechanism we are having. Okay. So this is the 4-bar mechanism, and let's suppose, let me first write down the names as well. This is point A, this is B, this is C, and this is D. AD link is fixed. Okay, AD link is fixed, everyone. Okay, if you have any doubts, please ask in the live chat box, or you can mention in the comment box also. Is it clear, everyone? Okay. Now, see, in given details, what are the given details here? Angular velocity of link AB, it is given, and length AB is also given. Any random value you can take. Okay, any random value you can take, because just now simply we are focusing on how to draw velocity diagrams. We will solve one question also. Okay, don't worry about that. But first of all, we need to know the steps that we need to take here. Okay, so that's why any random value you can assume 2 radian per second, 5 centimeter for AB link. Okay, so that is there. Now, if these details are given, first thing you can tell me that you can solve velocity of velocity of point B with respect to A. How you will write? Link length AB multiplied by omega AB. Got it? This you can write very easily because omega is given, AB dimension is also given. So angle, simple velocity of point B with respect to A can be written as AB multiplied by omega AB. This basic thing is clear to everyone? Okay. Right. Here I will write it. Okay, no issue. Now, we need to draw the velocity diagram. So for that, what we need to do? Please everyone understand here. We need to draw the velocity vector in this configuration diagram. Actually, this is our configuration diagram of a given mechanism. This is our configuration diagram of a given mechanism, right? On this configuration diagram of a mechanism, I will show all the velocity vector. And secondly, what we will do, with the help of those velocity vector, we can draw the velocity diagram. So step number 1, draw the velocity vector. So first of all, point B with respect to A is under rotation and it will have a velocity this much. So whatever the magnitude it will be having, right? Whatever the magnitude it will be having, based on the values you can calculate, so that is not an issue. Now, first of all, velocity of B with respect to A will be written as like this. Velocity of B with respect to A. Most importantly, you need to remember this point. It will be perpendicular to link AB. It will be perpendicular to link AB. Yes or no? Just now we have discussed this thing. This velocity vector will be perpendicular to link AB, right? Is it clear? Okay. So velocity of B with respect to A, will be perpendicular to link AB. So this length I will draw based on the magnitude that we are getting here, because both the values are given, I can calculate it, no issue. Based on the magnitude, I will draw the length of this vector also, right? Okay, fine. This is done. Now, next thing is velocity of point C with respect to B. Velocity of point C with respect to B. For that, we need to understand what kind of motion point C will perform with respect to B. Whenever I will say with respect to this point, it means with respect to that point means what? That point becomes the reference point. So when I will say velocity, okay, when I will say velocity of C with respect to B, it means B is my reference point. B becomes our reference point. Okay. So next step is to draw the velocity vector of C with respect to B. Velocity vector of C with respect to B. Now again C with respect to B, if you observe from B I am observing C, C will be under rotation because of turning pair. Definition of 4-bar mechanism, 4 links and all the links get connected with what? Turning pair. Turning pair allows only rotation. Turning pair will always allow only rotation. Remember this point. So C can rotate with respect to B. So velocity vector C with respect to B I need to draw. Again that velocity vector will be perpendicular to, it will be perpendicular to link BC, right? Because point C will be under rotation if I observe point C with respect to B. You will say, sir, why only rotation? Because B at this this joint, if I am talking about, these joints are what? Turning joint or turning pair I can say. So turning pair always allow rotation only. So C can rotate with respect to B only. Okay, with respect to B it will be rotating. So the velocity vector will be like this. Now you will be asking, sir, you are drawing a velocity vector on both the sides. Why is it so? I am drawing velocity vector like this on both the sides. Because at this moment I am not sure about whether BC will be rotating anti-clock or clock. If it is rotating clock, this vector will be correct. If it is rotating anti-clock, this vector will be correct. At this moment I am not sure about the rotation, whether it is clock or anti-clock with regards to BC link. So that's why I have drawn on both the sides. That's why I have drawn on both the sides. It will be cleared in the velocity diagram. So don't worry about this. So what I have done, on both the sides I have drawn the velocity vector. This velocity vector is velocity of C with respect to B. Fine. Now coming to the velocity of C with respect to D. Velocity of point C with respect to D. Next. Again, if I observe point C with respect to D, again it will be rotation because all are turning pairs. Turning pair always allows rotation. Only rotation it will allow. So point C will be under rotation with respect to D. Again, velocity vector C with respect to D will be perpendicular to link CD. So draw the velocity vector accordingly. Like this it will be there. Now again, for this moment I am assuming I don't know whether it will be rotating clock or anti-clock. So that's why on both the sides I have drawn the vectors. That's why on both the sides vector I have drawn. If this CD link moves clockwise, this is correct answer. If CD moves anti-clockwise, this is the correct answer. Right? That's why on both the sides I am drawing the vectors. If all the velocity vector you have shown in the configuration diagram of a mechanism, now next what we are going to do, we will draw the velocity diagram. At this point, if you have any doubt, please guys mention in the chat box or in the comment box. If you are watching this lecture, okay, later on, if you have doubts in any of the lectures, okay, again I am telling you, in any of the lecture, if you have any doubts or any confusion or any questions you have, please mention in the chat box or in the comment box basically, and I will reply as soon as possible. You can mention your concerns in the comment box, right? Okay. Now the very first step, guys, please understand, the very first step in order to draw the velocity diagram is see the fixed points. Fixed point will be point A and D. So I will first of all mention fixed point A and D. Fixed point I have mentioned A comma D, right? Why the fixed point I have taken? Because these are the fixed, they are not moving, so I can directly draw anywhere, no issue. These are the fixed and also a reference point. Now velocity of B with respect to A, I know the vector direction as well as the magnitude. I know the magnitude as well as the direction, so I can draw this vector. So what I need to do here, guys, everyone see, this vector I need to draw as it is from this point A. As it is I need to draw. Okay, make sure that same direction you are following. Direction we have to take care here, very important. Now, next what I will do, okay, next we need to mention that we got a point A, point B, sorry. We got point B here. Because this vector is representing velocity of B with respect to A. So this point will be point B, okay, with respect to A. So in order to draw a velocity vector here in the velocity diagram, we need a reference point. Reference point A was there, which was fixed point. So I have drawn the B with respect to a velocity vector, no issue. Next, what I will do, I will draw the velocity vector C with respect to B, because B is available here. When I am writing C with respect to B, B is my reference point and B point is available here. Directly this velocity vector, I will put it here, okay. Magnitude I don't know, but direction I know. So directly as it is, I will put it here, okay. As it is, I will put here, like this. Second, C with respect to D, point D is available. So next vector I will draw with respect to point D. The direction of C with respect to D is like this. With respect to D, I need to draw. I have drawn. So now let us mention the vectors. This was C with respect to B and this was C with respect to D. Right? Now both the lines are intersecting. Both the lines are intersecting. When both the lines are intersecting, this point becomes what? The intersecting point becomes, well, point C. That point becomes point C. That point becomes C. Okay, so let me write it here. These points are what? A comma D, fixed points. Okay. So you can ask this question, sir, why A and D you have mentioned with same point? Arey, with respect to velocity, both points have what? Zero velocity. So same point will be there, na? Okay. Don't be confused. Sir, here point A and D are different. Here you have shown with the same point. This is the velocity diagram. Both the points having same velocity. So same point will be there. Okay. Now, very, very important point. This vector is representing velocity of B with respect to A. Now, velocity of C we are observing from B, so arrow will be drawn like this. Velocity of C we are observing with respect to D, so arrow will be like this. This vector, what? Velocities. This is B with respect to A, C with respect to B, C with respect to D. Is it clear? So this is what we have as a velocity diagram. Now, as I told you, now we can tell about the sense of rotation of link BC and CD. I told you, when I have drawn this velocity vector, I told you I don't know BC is moving clock or anti-clock. I don't know. Right? I don't know about the clock and anti-clock. Similarly, I told you that CD link is rotating clock, anti-clock. I don't know. This answer we will be getting from the velocity diagram. So I have drawn the velocity diagram complete. Right? Now, second thing, how we will understand? Just see. Velocity vector of C with respect to B, velocity vector of point C with respect to B is having upward arrow. In this direction it is having arrow, which means this is correct. And if I observe C with respect to D, it is like this. So this one is correct. Are you getting my point? Now when this is correct, it means link BC will be rotating like this and link CD is rotating like this. This is a very, very important point, guys. This is a very, very important point. Everyone, please understand again here. C with respect to B. Why this arrow, upward arrow I have mentioned? Because this is a velocity diagram. C I am observing with respect to B, so arrow will be like this. C point I am observing with respect to D, arrow will be like this. Clear? Because these are the relative velocity. For relative velocity, you need to see what? The point from which you are observing. You need to know from which point you are observing. So relative means what? With respect to something only, na? So velocity of C I am observing with respect to point B, then only the relative term comes. So B I am observing towards C, so this arrow will be there. C I am observing with respect to D, so this arrow will come. So from the velocity diagram, it is confirmed that CD will be rotating clockwise, link BC will be rotating anti-clockwise. Obviously different angular velocities will be there. Okay, and you will see some questions also where they will be saying find out the angular velocity of link BC or CD also. Is it clear, everyone? Okay. So this is what we have as velocity diagram. Okay. Any doubt regarding how to draw velocity diagram? Any doubt? Tell me. Is it clear how to draw this velocity diagrams? Again, I'm explaining you all the steps. Okay, again I'm explaining all the steps. Okay, please see. First of all, they will provide you one configuration diagram, right? That configuration diagram, okay, that configuration diagram you have to use, and in that configuration diagram you will be giving some angular velocity, definitely some angular velocity of a link, and its dimension will be given so that I can calculate any one of the velocity vector. I have calculated this velocity vector and I will represent this velocity vector here in the configuration diagram, right? So value is given, so magnitude, direction, everything is understood. Fine. About other points, when I am writing C with respect to B, I don't know the magnitude. I don't know whether it will be in upward or downward direction. I don't know. Only one thing I know, that it will be perpendicular to the link. It will be perpendicular to this link. C with respect to B will be perpendicular to BC. C with respect to D will be perpendicular to link CD. Like this information we know. Accordingly, I will draw the vectors here. Now coming to the velocity diagram, fixed points A comma D. A comma D is the fixed point. First of all, A comma D I have mentioned here. Now using reference point A, I will draw this vector. I will draw this vector here with same direction. Same direction I need to follow, na? Same direction I will put it here. So what I am getting this point B. This is the point B here. So this point B got, okay, we got this point B. Now B becomes a reference point for this vector. So this vector as it is I will put here, okay, as it is I will take it from here and I will put it here. Only direction is confirmed here. Direction means what? Perpendicular to link BC. This vector I will put it here. Fine. Similarly, C with respect to D vector I will draw considering D is a reference point which is available here. So this vector I will draw like this. Now both the vectors are intersecting. So the common point will be what? Our C point. Common point will be what? C point. So this triangle kind of shape will be forming. No, it is not necessary that always triangle will be there. Sometimes you will get a straight line also. There are some examples, there are some special cases where you will get straight line also. Not necessary that always triangle you will be getting, right? Remember this thing. So this is the velocity diagram. Each vector is representing velocity vector. Now then I have told you B with respect to I have written now. So B point I am observing with respect to A. So arrow will be like this. C point I am observing from point B, arrow will be like this. C point observing with respect to D, so arrow will be like this. So these are the basic things we need to understand. Now when it is confirmed that C with respect to B like this, which means this one will be the correct answer. When this is the correct answer, link BC will be rotating anti-clockwise. If it was rotating clockwise, then this one answer, this vector direction will be the correct answer. Okay, so that's why I've told you from the velocity diagram we will easily confirm whether link BC is moving clock, anti-clock or clock. Directly it will be understood from the diagram itself. All the steps I've mentioned here, guys. Still you have any doubt, you can mention in the comment box also. I will definitely address all those points in the upcoming lectures, because this velocity analysis we are going to, in this velocity analysis we are going to take almost 3 lectures, and in that 3 lectures we will solve gate, previous year questions. Okay, so I will understand like how much you are able to get all those information regarding velocity analysis, because we will be solving questions, right? We will not just discuss the concept, we will solve problem also. So when you will start solving problem, then you will understand whether everything is clear or not. Right now I've told you one concept. I know many people have understood it, but when it comes to solving numerical, obviously some students will face difficulty. So always remember, until unless you have not practiced numerical, don't assume that your preparation is over or you have understood the topic. No matter whatever the subject or topic it is there, you have to attempt questions, you have to solve problems. Then only you can say that now you have understood the topic. Now you have learned the topic. Learning will be there when you actually solve question, because when you actually solve question, you are implementing all the concepts that was discussed in the class. All the understanding that you have taken from the lecture, you will be implementing in the questions. And if you are getting right answer, it means you have understood correct. You have understood the topic correctly. Okay, you have learned the topic basically. It will be cleared, it will be okay, it will be clear or it will be understood only when we have solved problems. When you are not solving question, it means you are not understanding the concept. So that's why solving problems is very, very important. That's why in the classes I'm always stressing on this point. Without solving question, you can't say that you have prepared the topic or you have prepared that subject without solving questions, right? Okay, so this velocity diagram is clear. Now moving on to the question part. There is one question that I will give you, okay, which was asked in GATE 2019, guys. GATE 2019, this was the question asked. You have to solve this question with the velocity diagram approach. Okay, we will solve later with the I-center approach also, but you need to solve it with the first velocity diagram. Again, this is a 4-bar mechanism. Same thing. AB length, angular velocity they have given. Dimensions are also given. Whatever we have discussed previously in the example, everything exactly same. Only the configuration diagram has changed. Only the configuration diagram has changed, guys. Is it clear? Fine. So this question I'm expecting that everyone will be able to solve. Okay, I'm expecting everyone will be able to solve this question. So I want everyone who are attending the session live, please mention your answer in the comment box. The solution part we will discuss in the tomorrow's lecture. And we will solve lot of questions from the GATE previous year question. So please don't forget to attend tomorrow's lecture, which will be part 2 of velocity analysis, where we are focused on more numericals. Concept we have discussed in lecture 1 of part 1 of the velocity analysis. Numericals we are going to discuss in the part 2. Is that clear, everyone? So I want everyone, please solve this question with the velocity diagram, and if you got the answer, please mention in the comment box also, and tomorrow we will discuss the solution, right? Okay, guys, so my request from my side, if you have any doubts or anything or any topic which you feel it is tough or you're not able to understand well in this theory of machine subject, no matter from any of the topic, any of the chapter, whatever the syllabus, GATE syllabus is there, from that any topic from theory of machine subject you are facing difficulty or it is like very tough for you to understand, please comment in the chat box, or you can directly mention in the comment as well that you want a lecture on this topic. I will definitely bring one live lecture on that particular topic, right? Teen saying question, sir. So this is the question as a homework. In tomorrow's lecture, I am giving you the solution as well. And remember, tomorrow lecture will be very important because we will discuss all the questions. In tomorrow's lecture, only questions will be there. Maybe voice is low. Please check your audio, guys. Okay, please check your audio. Definitely from our side, audio is clear. Okay, please check your connection. Definitely from our side, audio is clear. I've checked. Okay, so what I'm saying, please understand this question is as a homework for you. In tomorrow's lecture, we will solve all PYQ related to the velocity analysis. So be prepared for the tomorrow's lecture, guys. Right? With the velocity diagram, we will solve first, and then we will go to the eye center approach also. But we will solve first PYQ questions of the GATE examination. Right? And if you have anything like this topic you want from the theory of machine, whatever is mentioned in the GATE syllabus in theory of machine subject, in any of the topic, if you are facing difficulty, please mention in the comment box. I will bring one live lecture on that topic. Okay? And I will explain you all those topics in which you are facing difficulty. Fine. So now I will end this session, but tomorrow's session is very important. Don't miss it. We'll discuss the solution of this one also, and PYQ questions also we will be discussing. Right now I am in 12th, tips for JEE, please. See, right now you are in 12th, so actually this foundation course is for those students who are currently in engineering and the subject is theory of machines. So I will better suggest go for JEE classes where you will get all the support, guys. Okay, so this class is concerning with the engineering students of mechanical engineering branch, where we will discuss theory of machine. So you have to first clear your JEE exam, then enter into engineering, then we can have a discussion on theory of machine, right? Okay, guys. Thank you so much. Bye-bye. We'll meet tomorrow.